Hi, this is Mrs. Vaughn, and I'm going to give you an example of dividing rational expressions. So I picked a hard one. Sometimes I give you easy ones for the examples and then make you do the hard ones on your own. So this one isn't really hard. None of them are hard. So we have x squared minus 3x minus 40 over x squared plus 8x minus 20 divided by x squared plus 13x plus 40 over x squared plus 12x plus 20. Okay, so just like whenever you divide by a fraction, you actually multiply by the reciprocal. So we're going to multiply by the reciprocal. Okay, so I'm just going to rewrite the problem and flip this over and multiply it. And then we go back to just multiplying them together. Oops, that's a 40. Over x squared plus 8x minus 20. I'm going to multiply by, I'm going to put this on the denominator, x squared plus 13x plus 40. And this is x squared plus 12x plus 20. So notice the numerator from here is now on the denominator, and the denominator is now on the numerator, and that's called the reciprocal. All right, so now we're multiplying two rationals. Our first step is factor. All the expressions. Okay. All right, so I need two numbers that multiply to negative 40, two factors of 40, that add to negative 3. So 1 and 40, 2 and 20, 3, 4 and 10, 5 times 8. There we go. So I have negative 8 has to be a negative because it's a negative 3 and 5. So my factors here are x minus 8 and x plus 5. And remember, we can put all of these in the same, all the numerators in the numerator and then all the denominators in the denominator. Okay, so down here, I need two numbers that multiply to negative 20 that add up to 8. So 2 and 10 does, and this is a positive 8, and we need a positive and a negative, so I have 10 and negative 2. So I have x plus 10 and x minus 2. Okay, so here I need two numbers that multiply to 20 that add to 12. So 10 and 2 again, but they're both plus. So x plus 10 times x plus 2. And then two numbers that multiply to 40 that add to 13, and 5 and 8 also add up to 13, so we're going to use those. So we have x plus 5 and x plus 8. All right, so let's look for any common factors that we have in both the numerator and the denominator. So I have an x minus 8 here, but this is an x plus 8, so they do not match. X plus 5, I have an x plus 5 here. I have an x plus 10 here and here, and x plus 2, that's an x minus 2. So we'll multiply out what we have. And this is our answer. You may, if you have a multiple choice and you want it, and this is not the form it was in, you FOIL it out. So here I have x squared plus 2x minus 8x minus 16 and x squared plus 8x minus 2x minus 16. So this would be equal to x squared minus 6x minus 16 over x squared plus 6x minus 16. And remember, we cannot cancel these numbers that are the same because they are connected with plus and minus to other numbers. So this is an entire polynomial. You cannot. Factors are different. All right, are there any excluded values? Now remember, this is wherever the denominator would be 0. So we started with this problem, and this was a denominator. Then we multiplied by this problem where the other part was the denominator. So we need to look at more than just our denominator here. We're going to look at all of these factors plus these, because these were originally in the denominator for the original problem. So I need to see what x plus 10, set that one equal to 0, x minus 2 equal to 0, x plus 5 equal to 0, x plus 8 equal to 0. We already have an x plus 10 equal to 0, and we already have an x, oh, we have an x minus 2, so we have to do the x plus 2 equal to 0. Okay, so we have a lot of excluded values. So x is equal to 10, x equals 2, x equals 5, negative 5, x equals negative 8, and x equals negative 2. These are all of our excluded values. So x cannot equal 10 or 2 or negative 5 or negative 8. Okay, so this would be our excluded values.